So one of the great mysteries of the ancient world is how on earth the ancient builders moved the gigantic stones used in the construction of the Great Pyramids and other megaliths of the ancient world. Tens, hundreds, even thousands of tons moved across the Earth's surface and moved into their final positions with near expert and pinpoint accuracy. All of this without the benefit of modern transportation and lifting technologies. The ancient peoples just liked making life exceedingly difficult for themselves, or did they have techniques and tools which made these feats easier, or at least practical enough to enable continuous and prolific building? Being human like us, it is difficult to imagine thousands of people straining every fiber of themselves to the max just to move titanic stones only mere inches in a day, a situation which would be sure to cause boredom and threaten labor morale. There had to have been ways to expedite and maximize their physical efforts, but what were some of those ways? Many ideas have been proposed, some including ancient extinct waterways, even man-made canals. There even seems to be some evidence of this around the Great Pyramids in ancient Egypt, as well as the pyramids in Mexico. And we see here by these pictures that it's certainly possible for large rivers and lakes and other waterways to go extinct. But this still doesn't explain how these massive stones were moved across land and into their final positions. Everything from ancient mega machines powered by beasts of burden to lower Earth gravity in ancient times have been proposed. But one curious idea which seems to crop up occasionally around discussions of megalithic building relate to an alleged sonic technology. These are stories that describe an almost mythical technique which seemed to defy gravity and friction through the power of sound alone. One such story describes the construction of fortifications around the citadel of the ancient Greek city of Thebes by Amphion and Zethus, the twin sons of Zeus. While Zethus struggled to carry his stones by muscular power, Amphion played and sang loud and clear on his lyre as rocks twice as large as himself followed in his footsteps. One thing we know is that most legends have some basis in reality, even if loosely. For there to be so many of these stories, it seems that they had to be more than just myth and legend. In my previous sonic videos, I showed the ability to move nearly 200-pound boulders across an outside carpet using only one finger, not with special preparation or super strength granted by one of my bionic exoskeletons, but instead by interesting interactions between friction and sonic vibrations. One such type of interaction is called acoustic lubrication. This occurs when sound permits vibration to introduce separation between sliding surfaces, greatly reducing the friction and making them easier to move. Another type of interaction is called surface acoustic wave, also known as SAW, or more scientifically as asymmetric unidirectional frictional sliding, or what I like to call sonic propulsion. This occurs when particles on the surface of an elastic material or substrate move due to Rayleigh waves. These are longitudinal waves that propagate in the direction of travel. A slider arranged on the surface of this substrate will be driven along with these particle waves by frictional force. This frictional force is proportional to the external load of the slider as well as the frictional properties of the slider and substrate. The following clip will describe the general idea of these principles I'm envisioning as relates to megalithic building.
The viewer clearly describes subjects moving large rectangular blocks. Part of the movement appears to lift the blocks off of the surface such that they float while the subjects guide them into place. Thus, the subjects are not lifting the large blocks. Something else is doing that, but the subjects are guiding the blocks that appear to be floating in mid-air. The viewer describes how the large blocks are moved up ramps while being assisted by energy. It is a combination of both low and high tech. Because of the energy that lifts the blocks, moving them is not difficult. Daz notes that it is as if the blocks are sitting on a cushion of air. Many of these perceptions were recorded live in riveting detail.
Okay, yeah, so there's definitely something solid. It feels blocky. So it's solid. It feels man-made or manipulated. Positioned. Very strange this. The energy, this feels like there's an energy involved. So I'm just going to do it like this, because this is how it feels. So it's an energy. And it feels buffered. Or it feels like it's buffering. Almost like wind, but with an element of sound. I can hear a hum, a deep, low noise. Not annoying, but there's a noise there and it's everywhere. So yeah, solid object, solid. Blocky. These feel moved. I want to say pushed by life, manipulated, but pushed isn't right. More like assisted into position. Yeah, there's more than one. There's groups of these guys, and some maybe even pulling. Yeah, so it feels like, definitely feels like there's quite big, solid, heavy man-made structures or objects here, and they feel like they're being assisted into position, almost like pushed and pulled, but that doesn't feel like, the pushing and pulling doesn't feel like it's the only or primary source here. There's this energy, and I can't exactly tell where this is coming from at the moment, but it feels like it's everywhere around the life and the structures. And this feels like it's buffering and blowing, and it kind of has this cyclic, repeating but powerful motion. It buffers all around, dissipates outwards slightly, and it does feel like it's creating some kind of buffered motion, almost like I want to say it, you know, I'll have to AOL this of hovercraft at this stage, because it kind of feels like it has that kind of motion where it kind of like pushes up and outwards. Yeah, in a skirt type of effect, pushes up and out, and it just feels like there's something here above it. So yeah, almost like a heavy solid object on a cushion of energy, buffered air, energy, noise, all one kind of mechanism really. So it feels like, hard to describe, it feels like something coming up and around and then up again, moving up and around and being manipulated. This is definitely structures. This is definitely solid, heavy. Man-made structures. I'm gonna have to AOL blocks. These feel like they're being assisted and manipulated into place, rising, up and around, rising, as part of some grand structure. And I feel like they're being placed, being moved, positioned, placed. Some of it's manual labour, but it does feel assisted by some kind of, I want to say sound energy. I'm not sure sound is the right word. I mean, sound is involved in this, but it's not wholly sound on its own. It's almost like a sound plus. Yeah, so they start off lower, they are moving up and around a structure and up, almost like on a platform. Assisted movement on a platform, up and around a structure into place. That's what I get at this stage. Detail here. So I'm going to slide and describe more detail. Okay, definite block feel here. Feels heavy, solid, and there are men or males. There's more than one. They're at all sides of this thing. There's a motion. So there are males and they're moving or helping a structure be positioned. Now this motion feels it's fluid. Now there is a manual element to this, but this doesn't feel strength based. It feels more like positioning. So not strength based. I don't want to say wholly on this though, because there is this interaction. There is this sound interaction. This buffered, yeah, buffering. So we have the solid here, and we have this buffering, and it's pushing against, and it pushes back down, but it's very strange because it's all cyclic at the same time, all repeating. I can't quite describe it. I've never felt anything like it before. I want to say magnetic, but it's not magnetic, but it's got a push and a pull. And it's loud and penetrating. There's a hum that just feels like it goes right into your bones. Yeah, so it's pushing, moving this. Pushing and moving this structure into place here. Very solid, very solid structures, and they all seem regular actually, regular shape. And it does, I hate to say it, but it does feel quite blocky, like blocks. You know, proper three-dimensional objects here. They're just being pushed, pulled, manipulated into place. I want to say floated and fluidly, because everything feels fluid. It doesn't feel like there's jerky motions. And it feels like the males are there more as guidance and manipulation. They're almost like guiding and moving, making sure it doesn't slide off. Maybe there's a tendency for it to slide off. I feel that it could slide off to the if you're behind the stone, or I say stone, if you're behind the object here. So there's definitely life involved. These feel male, more than one, working in groups. They assist each other. Definitely a team style relationship. And there are multiple groups. This feels past because they just feel clothed basically. basic clothing, dark skin, and yeah, they seem to be involved with objects which feel blocky and solid and heavy. And it feels like they're moving these. So, you know, we have a 3D block here and it feels like it's being moved, pushed and pulled. And this feels like it's been moved into place into some grander, larger structure. And it feels like this is a big plan. This is a big plan thing that's going on here. And yeah, they're coming up and around. And oh, it feels like a huge, big rising. I don't know if I got the angle right here. It might not be out rising this much. It feels like something's rising. But there's also a platform right outside. And these life are moving blocks. They're here, you know, manipulating moving blocks, and there's another block here, and there's these guys moving it. I want to say sliding it. Sliding, moving these blocks upwards. Up a structure. And you know, they come up one part, and then they go around a straight edge corner, and they come up another one, and there's another straight edge corner here. And all the time they're moving along and up a gradient. It's raised. It's a raised surface. Yeah. Blocks. Just keep seeing blocks moving. And this man, they are kind of hands-on. They're like pushing, moving, and there's more than one. It feels like about 6 to 8, maybe no 4 to 8 per block, but depending on the block. Some of the blocks there's different sizes. So yeah, some of them are huge, and some of them, I don't know, they have a different shape, a different edge. That's not a very good sketch. I can't draw it. Yeah, they feel like they have an edge or a lip to it. An extra edge or a lip to them. Maybe a corner. Maybe it's a corner part or something. Life forms, probably male, probably from the past. They feel like they're working with man-made, moved, naturally carved or naturally made large heavy structures, and they feel like they're moving them into position, moving them into place over a distance. Part of this is done with labour, but part of it's done with an energy which feels like it's a buffering cyclic energy, very slidey, a bit of noise involved, which feels like it comes from a technology and a.
Okay, so even though this information was allegedly derived by remote viewing, let's try to keep an open mind, because the principles seem to be at least rooted in a type of ground effect science. The viewer seems to be describing similar principles concerning acoustic lubrication, where large stone blocks are coasting or actually buffered against the ground by a type of cushion of vibrational energy. If we look at the experiment here, we see what I call my vibro sled that is loaded down with almost 300 pounds, and it's practically coasting across the ground by itself, like a hovercraft, as though there's very little friction with the ground at all. So in this account, the blocks were not levitated high into the air, but were actually rendered near frictionless, or at least enough to be easily maneuverable like an air-cushioned vehicle, which is actually another type of a ground effect machine. So we've seen that this is indeed possible on a small scale, and there is no reason to believe that it is not possible on a megalithic scale if the adequate vibrational energy can be catalyzed. On a flat surface, less friction is certainly desirable. But what about when an incline or gradient comes into play, like say a ramp to the Great Pyramid? In the remote viewing clip, the viewer describes the great blocks being pushed around or against the gradient rather easily. But is this possible given the fact that on an incline, less friction would reduce the force that is counteracting the force due to gravity? Looking at the forces acting on a weight resting on an incline, as shown in the diagram here, we can see that the contact between the load and ramp becoming frictionless would lead to the block sliding downwards against the workers who are striving to push the block up the ramp. This would be where asymmetrical sliding might come in. And as aforementioned, a rougher surface with greater friction would actually be advantageous in getting a load to possibly move against the gradient and thus up the incline. This is logical, as even with a wheeled vehicle, greater friction would enhance movement up a steep incline, as there would be more traction. And it would follow that the steeper the incline, the more traction and friction would be needed. But on a flat surface, of course, a vehicle like a hovercraft operates better with as little friction as possible. And so what this shows is that friction is not always something to be overcome. At times that can be harnessed to one's advantage. The experiment here shows the movement of a vibrating object across an outside carpet, thus demonstrating the role of friction in frictional sliding or surface acoustic wave. The friction being proportional to the roughness of the surface as well as the magnitude of the load. But there may be limits to the efficacy of a rougher substrate, as extremely rough surfaces may hinder any movement at all, especially if the rough particles begin to dig into the moving surface. There will likely be an ideal friction range, which depends on the hardness of the moving surface. The harder the surface, the greater the friction can be, without becoming a liability. By contrast, a vibrating object on a smoother surface may not move as readily, but it will move easily due to acoustic lubrication. But frictional sliding will be limited due to the lack of friction. Friction is actually needed in frictional sliding. Here we can see the movement of a vibrating object against a gradient. So we see that it is indeed possible for frictional sliding to move an object uphill. But the question is would it be strong enough to move heavier objects against the same or even larger gradients? If the weight of the object exceeded the ability of the surface waves to move it, then the object will either stay at a standstill or it may even slide back down under the influence of gravity. But there is still a measurable unidirectional force. The experiment here shows that the vibrosled is moving in the direction opposite the direction the piston is pointing. So we see that, at least for this type of design, that the unidirectional force will be in the direction opposite the piston. So if I want the device to ascend the ramp, what I do is face it backwards as shown. To quantify the strength of this force, I increase the incline and add about 5 pounds to the contraption, so that the vibrating sled will either remain still or slide in the opposite direction. I then measured the force it took to manually pull the sled up the ramp. I took 3 trials and took the average. I then reversed the direction and hence the polarity of the sled's vibrations and ran 3 additional pulling trials and took the average. So taking the difference of these two averages shows that there is a quantifiable difference in the force required to pull a direction when facing one direction as opposed to the other, requiring less force when the piston is facing away from me, as would be expected from the aforementioned principles. But if this unidirectional asymmetric force is inadequate after a certain magnitude of load, or say even a magnitude of gradient, to move the object uphill, all is still not lost, as a simple counterweight system can be used in conjunction with the sound vibrations. In this next experiment here, I have a vibration sled at the bottom of a steep incline and loaded with an additional 10 pounds of weight. A twine attached to the sled and is run along the ramp and over a curved surface for easy sliding. It is then attached to a 10-pound counterweight. When inactivated, the system is simply in equilibrium and there is no movement. But when activated with vibrations and brought into resonance mode, the friction is acoustically reduced and the sled is pulled up the incline by the counterweight on the opposite end until the counterweight makes contact with the ground. In this early experiment, the sled is being pulled in a direction opposite the unidirectional friction force discussed previously. Reversing the sled's direction also results in its rise, but in this position, the rising force is slightly stronger and faster, as the unidirectional force is in the same direction as it is being pulled by the counterweight. Thus, we can see that both frictional sliding and acoustic lubrication can be used together in this process. Now, if we could scale this process up to the 2.5-ton stones of the average pyramid stone, we might imagine adding a counterweight system to the pyramid such that an equal weight could be placed on the opposite end. This counterweight will likely be composed of a number of smaller, more manageable blocks, say about 10 500-pound blocks, which of course will add up to 2.5 tons. But they would be easier to move into place individually and placed into a type of counterweight sled or contraption. But even still, friction will still be a contender. Introducing acoustic lubrication to the 2.5-ton stone, and perhaps even the counterweights as well, might enable the workers to push the ponderous stone up the incline rather easily. Once the stone is up the ramp and to the next horizontal level, the counterweights can be disengaged and the vibrations can allow the maneuvering of the stone to its final position and finally put into place so tight that even a razor blade can't be slipped between the blocks. So it seems that the final few inches of the block's movements would be especially critical and would require great care and greatly reduce friction such that the blocks will not slam together by large forces. One investigator remarked that it seemed like the blocks were simply tapped into their final position with very little resistance and very little to any damage to the surface of the stones. Now, of course, in order to do all this, a vibrational sled couldn't be used. The stones themselves will have to be made to vibrate. So I'll discuss more about vibrating and resonating stones a little bit later. Now, a counterweight system becomes even more intriguing when considering what is known as the Grand Gallery internal ramp theory. This is a theory that was presented by French architect Jean-Pierre Houdin. It describes the Grand Gallery of the Pyramid of Cheops as being used as a tool to transfer the giant 60 to 70-ton granite beams that were used to build the relief chambers above Khufu's burial chamber, and to also build the flat ceiling of the burial chamber itself. Houdin's theory suggests that the Grand Gallery was part of a counterweight system, where a wooden trolley equipped with heavy counterweight stones slid down on wooden rollers that move on stone benches that run along the sides all the way through the gallery to help raise the granite beams on the opposite side through the external ramp to their respective positions. Houdin had his team calculated that with this ingenious counterweight system, it could have allowed fewer than 200 men to easily move the 60-ton beams to the upper part of the pyramid. So here we see an illustration of this idea. The document states that the wooden slides that held the beams were attached to the trolley using a rope system. Then the regularly spaced rectangular holes found in the lateral stone benches were used to fix wooden beams that kept the wood rollers of the wooden train that held the trolley in line as they slid on the lubricated benches. He says there are scratches on the face of the stone benches that show proof that something massive was moving within the gallery and exerting tremendous pressure against the vertical face of the lower stone benches. Jean-Pierre also says that there are chisel marks in the higher walls of the gallery, which seem to suggest that a set of wooden beams were fixed there to guide the upper part of the trolley in order to give it lateral stability. Now, this theory is fascinating and has been simulated in virtual reality with all the measurements and features matching what they would have been in reality.
The external ramp that Jean-Pierre imagines isn't enough to explain how the huge granite blocks were moved into the heart of the pyramid. On a ramp with a 7% incline, you'd need 600 men to haul a 60-ton block, but coordinating so many men would be an impossible task. Jean-Pierre thinks the key to the mystery is the Grand Gallery itself. He's convinced the gallery was the key element of a gigantic system of counterweights that would have made it possible for just 100 men to move the enormous granite blocks. The Grand Gallery is truly an impressive structure. 8 meters high, 48 meters long, and a 50% rate of incline, it has fascinated everyone who's ever entered it. The layout makes no sense from a ceremonial point of view. Could it have been built for practical reasons?
An additional question is, what if acoustic technology was used to aid in the counterweight system described by Jean-Pierre, much like the model acoustic counterweight system that I showed and demonstrated earlier? Those familiar with alternative theories for the Great Pyramids may have heard of Christopher Dunn's book, The Giza Power Plant. In it, Christopher Dunn theorizes that the Great Pyramid was an enormous acoustical device which was harmonically tuned to the Earth's resonant frequencies. This tuning is believed to have been achieved by deliberate positioning and measuring of the internal features to maximize its acoustic properties. Once in resonance, the piezoelectric properties of the stones of the pyramid substrate, which were crystalline in nature, will convert the vibrations from the earth into electromagnetic radiation for a beam of wireless energy which could be directed outside of the pyramid, similar to Nikola Tesla's Wardenclyffe Tower. The pyramid power plant theory also specifically mentions an alternative utility to the Grand Gallery, this time as an acoustic resonator rather than as an internal ramp with a counterweight system. The document here says that The utility of the Grand Gallery was to transfer the energy flowing through a large area of the pyramid into the king's chamber. This sound was then focused into the massive granite ceiling beams and caused them to go into oscillation. These beams then compelled the above beams to vibrate in harmonic sympathy. These sympathetic vibrations resulted in the entire granite complex becoming a vibrating mass of energy. Imagine the vibrational strength of thousands of tons of granite resonating in harmony with the fundamental frequency of the earth. Acoustic researcher John Reed relates that vocalizing the prime resonant frequency of a coffer located inside of the king's chamber generated reflective sound waves, which were so intense that it was like waves of water washing over the body. The question is, could these vibrations have been used not only to finish in the finished pyramid, but also in the very construction of the pyramid itself? If the pyramidal granite substrate did in fact have potential or potent resonant properties, then it seems to me that powerful vibrations could have been used to acoustically lubricate the massive blocks as they travel over the pyramid structure, as well as in its inner chambers. Simply moving such large masses over the pyramid structure would send the entire structure into resonance. Let's draw an analogy with a musical instrument like a violin. Let's say that Jean-Pierre Houdin's loaded wooden trolley is the violin bow, with the violin strings representing the pyramid substructure, and the violin body representing the earth itself. Thus, we could see that moving a 60 to 70 ton boulder along the Grand Gallery would induce an acoustic excitation in the gallery structure, causing it to vibrate at its resonant frequency and all of its harmonics, just as moving a bow causes the violin strings to vibrate at their resonant frequencies. Like the violin body, which amplifies the strings' vibrations via sympathetic resonance, so too would the earth vibrate in sympathy with the pyramid substrate. The Egyptians would likely have used some type of lubricating fluid to reduce friction between the trolley and the gallery guides, but the generated resonant vibrations could have reduced the friction even further. My experiment has shown that, at least on a small scale, acoustic lubrication could reduce friction to over 50%. Perhaps Jean-Pierre's 200 men per 60-ton block could be reduced even further, to probably 100 men or even fewer. In this case, there would be no need for external musical instruments, as described in some of my earlier postulations. But it might follow that a large number of musical instruments and or a large group of vocalizing people could further increase the acoustic vibrations and the resulting acoustic lubrication. For these human resonators, as I would call them, there would be no need for them to even physically touch the block at all. They would literally be part of a massive sonic vibrational system, which includes the earth and the pyramid. Since sound is the medium of energy transfer here, they will only need to vocalize to add energy to the overall system, aiding in the movement of the block in a kind of acoustic kinesis via singing, playing musical instruments, and chanting. Again, this would theoretically produce not only acoustic lubrication or the acoustic mitigation of friction, but it might also produce unidirectional movement against the gradient via asymmetric frictional sliding. As we can see in these experiments here, a vibrating incline substructure can indeed move objects up an incline. And by reversing the device, the same object can be made to descend the ramp. Perhaps there is nothing stopping this from occurring on a megalithic scale. If not, the implications could be huge in understanding how sonic technology might have played a role in constructing the pyramids. Now on this note, pardon the pun, let's take a look at what is called Nikola Tesla's earthquake machine. This machine is alleged to be one of several electromechanical oscillators. The original device is said to have worked by forcing steam into and out of several ports, pushing a piston up and down that was attached to an armature. This movement, of course, would have produced electricity, but Tesla also claimed that a later version of this device will cause such extreme vibrations in building structures. While experimenting with it, the device has supposedly generated such a resonance, even in his own building, that multi-ton equipment in the basement was moving around. Sound familiar? A little like sonic propulsion? Now, another version of this story claims that suddenly all of the heavy machinery in the place was flying around. Now, this sounds a little bit like sonic levitation. Now, if any of these accounts are true, then all of a sudden it appears that ancient megalithic sonic technology may not be quite so far-fetched after all. So we've theorized on the ability of vibrating sub- and superstructures, and the ability they could have had in aiding the movement of large objects within their confines. Going to my experiments with vibro sleds, the question is this: if the ancients did indeed move large stones over land with sound waves but outside of a sub or superstructure, then how could they have done it? Making a sled based on my models would be impractical, as it will require an enormous metal cavity as a resonator and a way to electromechanically excite it, not to mention trying to hoist a huge monolith onto the sled and off of it. Some people believe that the ancients had a level of technology comparable to our own modern technology, but perhaps based on vibrations instead of electromagnetism. There's a saying that there is nothing new under the sun, but even if this is not likely, this may still not be the end of the story. It is said that the pyramid blocks, obelisks, and other stones used in megalithic structures around the world actually ring when tapped sharply on their surfaces. There are even naturally occurring resonant rocks that are called ringing rocks. When they are struck with a hammer, they make a sound similar to that of a bell. At least one of the 720-ton colossi of Memnon in Egypt is claimed to emit a peculiar sound, possibly due to ambient temperature variations, giving rise to the story of, or the legend of, the vocal Memnon. The sound sounding like the striking of brass or a whistle. Now, these titanic structures were transported more than 420 miles away from the quarry at El Gabel and El Amar towards upper or southern Egypt. It seems unlikely that they could have been set on massive barges and then transported by the Nile as they would have been traveling upriver. Regardless, they at least would have partly traveled over land. But how? And how could acoustics have played a role? If we accept that these huge stones used in ancient megaliths do indeed resonate, then given their enormous size and weight, then actually the mere movement of these stones will cause them to vibrate. In fact, I theorize that the larger and longer the stones, the more likely they would have been to resonate when moved. The stones likely would have been loaded onto large wooden sleds. The sleds would likely have been moved over previously laid wooden tracks. A viscous fluid would likely have been used to lubricate the tracks. The remaining friction would have been sufficient to acoustically excite the mammoth stones into their own natural frequency. These resonant vibrations may have been sufficient to reduce friction via acoustic lubrication. This can be envisioned by pushing this office chair. The friction between the foot pads of the chair legs and the carpet causes the chair to resonate at its own natural frequency, which is a function of the dimensions of the chair, the crystalline structure of its metallic parts, and its construction. I don't have the equipment to measure the exact frequency, but the sound seems to be in the range of a decent-sized horn. The sound is generated just by pushing it over a surface of adequate roughness. Similar experiments and models could be developed to determine whether or not friction could be sufficiently reduced using this technique. We might expect that the multi-ton stones would generate a deep, low frequency and perhaps a number of harmonic overtones. Like with the previous grand gallery example, a number of people vocalizing and or sounding off at those same frequencies that the block is making may be able to acoustically add even more energy to the system, increasing the already present acoustic friction interaction already present just by moving it over the surface. So do these various theories and demonstrated principles form at least a loose scientific foundation for the cross-cultural memory of utilizing sound vibrations in ancient megalithic construction? Does this process reflect the African symbol of Sankofa, which means to go back and retrieve what has been lost? Vibration being the fundamental principle of the universe, then it follows that the ancients would have sought to learn all they could about it, to master and to harness it for a number of constructive purposes. Sonic and electromagnetic vibrations have been used for decades, for brainwave entrainment, for water cavitation, drilling holes through solid stone, and communication. Vibration is also claimed to have aided in the attainment of alternate consciousness, for healing, levitation, sonic propulsion, enhancing crop growth, as well as connecting to Earth energy and universal frequencies. So did the ancients have these abilities and perfect these principles? Is this the reason they went through so much trouble to build such precise structures and alignments? People still generally think of the ancients as primitive, but this is not the case. Looking at their magnificent architecture and their uncanny knowledge of the cosmos alone proves that they were every bit as intelligent as we are. Considering that the technology and knowledge that we've obtained in just the last 100 years, how much could our ancestors have achieved in hundreds, even thousands of years of continuous civilizations, like with the Egyptians, the Sumerians, the Nubians, the Greeks, and the Maya? It's hard to believe that with intelligence and time, such as they had, that they could not have arrived at a very advanced understanding of both nature and the universe. Some of their knowledge may have well exceeded our own in certain areas. Unfortunately, some of this knowledge may be forever lost, while other knowledge is only waiting to be rediscovered.